Class, is Professor Gavoor, and today we want to cover Chapter 13, Understanding Software, a Primer for Management. And this is an IT class, Information Systems, Information Technology. So understanding software, you'd think that should be a core part of the class. I would have made it like Chapter 2, Introduction to Computers and Understanding Software, but it's Chapter 13, that's okay. Today, last time I was kind of more excited about learning objectives. Today, not so much. Okay, so computing hardware. That's the stuff that you can drop and break. That's the stuff you can kick. It's the things in three-dimensional physical space, like your phone, like your laptop, like your desktop, like a server, like a mainframe, like a routing box, all the stuff that is physically made and produced to deliver computing services to everybody. So it's storage devices, input devices, output devices. Software is how these things run, what you tell the hardware to do. And it's really where the magic happens. They can't happen without hardware and software. And hardware, as we talked about at the beginning, faster and faster, and by Moore's law can store more and more, and etc. But it's the software that's the magic. I remember when PCs first came out, Bill Gates one time said, they'll be giving the computers away and you have to buy the software at some point because the hardware is not so important. You know, it's a razor blade. You could buy a razor without a blade, it's not functional. And it's the razor blades from which the companies make their money. Okay, so we did that. More learning objectives. And we get to, I was going backwards, I was not going frontwards. All right, so there's a layer, and I guess I'm calling it a layer cake. There's a user, which is like you and me. I'm using my computer right now to do this recording for you. There's an application that you use. I'm using on my iMac on my desk here the application to record this video. But you could use Microsoft Office, which is what PowerPoint is open on. Oracle, EA, Sports, Madden, NFL, if you're playing a game, I guess. And then the operating system. My operating system that I'm using here is the Mac OS X or OS Big Sur version, which has actually crippled part of my computer when I have to get it fixed someday. And then the hardware on which I'm doing it is a combination of many things. It's my Mac. It's the microphone I bought from Amazon to record and make my voice sound so good. It's the router that brings the internet into my house and the wires that connect it. Some more learning objectives. Yeah. So an operating system. This is you open the computer up and you turn it on and it says something like, welcome, what's your name? Who are you? So log in. It tells the computing system needs to be controlled. There's storage locations, there's memory, and there's any number of things you can do with that storage location and memory. So it provides a common set of controls for managing computer hardware. And it's the interface, because remember, everything is in bits and bytes. It's in zeros and ones. We don't think that way. We don't write that way. Actually, some people do, and it's a little bit scary how good they are at it. But it makes us easier. I mean, we type in language, and many languages across the world. And the computer needs to understand what we're telling it to do and then go do it. So the user interface, a graphical user interface like scroll bars. Our first computers had no graphical unit interface. It was like a typewriter. You would type code and you would tell it what to do. MS-DOS, before you had any Microsoft software on top of it, was really a pain to use. You had to learn the DOS language, in a sense, to get your computer to do what you wanted to do. Graphic user interface, like scroll bars, menus, things that we take for granted, have all kinds of programming behind them. You know, you buy a computer with 8 gigs of RAM, and the central processing uses how many of it. And you buy something with a hard drive, but how much of that hard drive, when you buy the computer right out of the box, is already has system kinds of controls and whatnot on it. I mean, it doesn't take up a lot of space, but it does take up space. Firmware and embedded systems. That's the software that's stored on the non-volatile memory chips. It's like you can't change it. And then embedded systems are special purpose software designed and included inside physical products. Almost everything we get has it on it. These kinds of firmware and embedded systems in it. My iPhone does, your Samsung does, pads, computers of all different sizes and ilks have both firmware and embedded systems. Gee, more into learning objectives. So when we talk about the platform, desktop software, enterprise software, platform is products and services that basically allow for the, one, development, but integration of software products and other complementary goods. Application softwares perform the work that users and firms are directly interested in accomplishing. Think Microsoft Office. That's a platform. Inside of it, you have word processing, this, that, the other thing, PowerPoint, which I'm using, Excel, which I use. It has Outlook for organizing your mail. It has MS Teams, which makes remote learning possible for North Park University. And you have that's a platform in which people develop things, and people develop templates that go into Microsoft Word. And if you take 5411 with me, which is the decision making for managers, quantitative decision making for managers, we use an application that sits on top of Excel that allows us easily to solve many of the problems, rather than having to take the blank sheet of Excel and put all the coding and equations in to solve a linear programming problem or a decision analysis problem. It does it for us. You can't do econometrics the way I teach it, and Professor Sunholm teaches it. And now, sometimes I teach it for him without data analysis, which is another application software that sits on top of, kind of embedded in Excel, that allows us to do regression analysis on a kind of a complicated basis. So desktop software is the applications installed on a personal computer, supporting the task performed by a single user. Well, I have Microsoft Office, which is a platform, is installed on all three of my computers. And North Park University has a cloud version. By the way, if you don't know, you can get the latest version of Microsoft Office as a North Park student. It's yours. If you just go to the IT page and search for it, you can download the latest version of Microsoft Office. Enterprise software. This is ERP Systems. This is Oracle, SAP, applications that address the needs of multiple users throughout an organization or work group. You're using an enterprise software when you register for classes using self-service. That is an enterprise software that North Park has, and everybody uses it to select their classes and then register. So, application software, apps, desktop products, and enterprise systems. Software products are offered commercially by a third party. That's what that means. ERP, enterprise resource planning, software packages that integrate many functions. Think of it as software packages that used to be separate, but now are all integrated, use access to one large database or set of databases, and can handle all of the transactions inside the company. Theoretically, if you enter a number once by hand using a keyboard, using an ERP system, that number should be available to whoever needs that information to do their job. And you don't have to, there was a time when I used to get printouts from one department and then type the pertinent information into my little local system to do my job. Well, that's not necessary anymore. The data is there for everybody to use, should you have the permission to do so. So application softwares, we're continuing with this. Managers are likely to encounter the following three categories. Well, there might be more. A customer relationship management system used to support customer-related sales and marketing services. We're going to talk about that separately, and I think we have a mini case study on it, the last one. Supply chain management, which is everything that you need to take orders, process orders, okay, and fulfill orders. That's one part of it. The other part of it is all the software necessary to manage your suppliers, to bring raw and packing materials into the company, to add value to them and make finished goods and do all of that planning, and then allocate that finished good inventory to your various distribution centers. That's a huge part. Business intelligence systems, these are how you take this mountain range of data that we talked about last week and integrate it into information that you can use to make intelligent decisions. What's missing here? How about general ledger? Ooh, geez, that's kind of important. I mean, the crux of any ERP system is the general ledger, and that's the accounting and finance side of things. That's where it all starts, and that's kind of like the backbone of it, because that's how management controls essentially all these other functions. The other thing is there's a human resource module. You have to know everything about your people to make them happy and get them paid and get them their benefits that they have selected and deserve, and do that in an efficient manner. So it's more than just these three things. It might be these three things from a day-to-day, well, no, the general ledger has to be part of this. I'm sorry. I mean, this guy Gallagher's good, but he missed this one. Database management systems. Well, you create this database, this mountain of database. There's millions. There's a defined finite number of ways in which to organize and sort the data. It could be structured, it could be unstructured. Most business data is structured, and there's a variety of different ways of doing that. So the software creating and maintaining and manipulating data. If we're generating the amount of data that we talked about last week, it has to be managed, it has to be stored, it has to be retrievable. It's like in a warehouse. If I could just keep getting product into my warehouse and putting it everywhere, if I don't keep track of where it went, when it came time to take the product out and actually deliver it to a customer, I don't know where it is. That's a database management system, is what it's supposed to do. Firms with common database systems and standards benefit from increased organizational insight and decision. Yeah, thanks, Gallagher. That's helpful. But what you want to do is, there's no one database for a ERP system. There may be several databases that are allocated, and I mean, that you need to do your work. So you take bits of data from here and bits of data from there and put them all together to do the work that you need to do. And there's software that has to manage all of that. Most of it is transparent to the user base. I mean, most people that use ERP systems don't know much about databases. Some people are specifically designed to, that's their life, is just maintaining and structuring and ensuring that the database is organized properly and the data inside of it is accurate. So that's a data management kind of job. So a database management system. You got all these activities happening. You could have a supply chain management system from Walmart, interfacing with supply chain management system within my own company, and let's say I'm Kellogg and I make cereal that I ship to Walmart. Then you have the CRM system that me as a supply chain manager might deal with my supply chain counterpart in Walmart, but the salesperson with the purchasing, with the merchandiser inside of Walmart, etc. And then you might have proprietary inside information in your own company, like how much you pay for your raw materials. You don't need Walmart to see that. They can probably guess. But if they had that information, they could say, okay, you need to make this kind of margin. Here's the price you should charge me, which may not be the price you want to charge them. So, and if you have personnel information on your people and the salaries that they make, that's proprietary. They talk about ERP. I don't know. I'm going to put something other than this, because I think ERP to me is the umbrella that goes over all of this. But that's a matter of perspective and definition, how you look at it. To me, SAP, Oracle, which are the primary kinds of software platforms that large companies use to run their entire business, to me is an ERP system. So the rewards and risks and packaged systems. Well, they can save you millions of dollars and turbocharge organizations. Certainly they can. They can do things that are fast, quick, efficient. They're written and rewritten and done by an army of specialists that are just doing that. They can, and here's something that they don't talk about a lot: streamline processes. That's what is the whole goal. Make data more usable and ease the linking of systems with software across the firm and key businesses. Firms that have systems that work smoothly internally then find it easier to partner with others. Early on in the days of ERP systems, SAP and Oracle, they would say, oh, can you communicate with this external software? Yes, there's a bolt-on thing for that. We can interface with them easily. Whenever I heard the words interface with them easily, I said, oh boy, that's going to be a problem. Because it's never easy. It's easy once it works. But to get it to work and get all the things lined up so that you can communicate effectively, usually it takes some effort. I think it takes less effort now because they've figured out better ways to do it. So efficient integrated enterprise systems make your firms more attractive acquisition targets if you're trying to sell your company, or make it easier to acquire other firms, because one of the hard things when you in a merger or acquisition of any kind is putting the two companies together, and whose system are you going to make them switch to your system if it's not the same? If you buy another SAP company, it's like, whew, that's kind of easy, but still the integration, you have to make sure all the data sets and all the data definitions and all that kind of stuff are match up. So that takes a lot of effort. But even if you buy an Oracle company or some other ERP system, they're kind of sort of structured the same way. They have their differences, certainly. So these are the rewards and risks. What are the risks? I mean, if you don't use a package system, like if you write your own software, well, you have to upgrade your own software, and it gets stale, and you have to have the expertise of software writing and the expertise of the business. So if you're writing, if you're SAP or Oracle and writing software that's going to apply to hundreds of businesses around the world in a specific application, you've got real good expertise you can tap on with all your customers. You've got real good expertise and subject matter experts inside your company, and you probably have the best quotas in the world working for you. If you're a small mom and pop shop company, you don't have it. Buy QuickBooks. Don't try to do it yourself. It's QuickBooks. What is it? It costs you $3,000, $5,000, $10,000. It doesn't matter. You'll never be able to write software that runs your whole company. Now, the risk is if you got to adapt to that. You got to learn to operate inside of that system. So that's something else. The other risk is whenever you buy a packaged third-party software like this that runs your whole company, there's going to be upgrades. And you have to eventually upgrade. You can say, well, I'm going to skip this one. But eventually, they're not going to support what you use anymore. And what you use, version 1, might be obsolete if the system is already on version 4. So at some point, you get a nice letter from the ERP company saying, you're still using version 1, we're moving to version 4. If you don't transfer to this, we're not supporting, there's no more support for your level of the business. To continue support From us, you have to have this level of this version. All right, so that was too much. Oh, geez, another learning objective I get to skip. Okay. Distributed computing, web services, and APIs. Distributed computing. What is it? It's a form of computing where people can be in different locations. People can work at home or work in the office and still be connected. I mean, I can't run the entire North Park enterprise on my little iMac at home. No way. But I'm connected to other computers at North Park, servers that have software on them, which are like the little mainframes, or maybe not even at North Park, but might be at a third party. The people that own the software, we may use their servers, and other people are accessing the same database. I can collaborate on a document with you through our Microsoft 360. So if you're writing a paper and I'm writing a paper together, we can collaborate at the same time. I'm going to write this paragraph, you write that paragraph, and then we put it together and I edit yours, you edit mine, and next thing you know, we're done. A server is a program that fulfills the requests of a client. Well, a server in a restaurant, what does a server do? Hey, I would like a Coke. Please bring me a Coke. They bring you a Coke. What else would you like, sir? I would like a hamburger and French fries and, blah, blah, blah. So in a hardware context, it's a computer that has been configured to support requests from other computers. It's kind of like the, Grand Central Station or Union Station in Chicago. All the trains come in and people get off one train and can get on another train or walk into the city. It's a place where things can mesh and merge from different places. In a software context, it's a program that fulfills these requests. So a client is a software program that makes requests of a server program. My client program could be my Microsoft Word. I want to access the document, please, that Manuel and Jane and I are working on. And it will go out and get me that document. I mean, it's like you don't see it happening, but it's transparent to the user again. You want it to be transparent to the user. The document comes up. I'd make my changes, and I resave it wherever it gets saved on some server someplace. And I could have a copy of it on my computer, or it could be in the document could actually reside in Microsoft Teams, which is also a client software that accesses information on a server someplace. It could be a North Park server. In other words, where we can share information. Canvas is a client software that I don't even know where that course information resides. Do we have server space at North Park for it, or do we get server space from Canvas for it, or some third party? Does it matter? It works. I use it all the time. It's reliable. It's transparent to me and you. So application server, software that houses business logic for use by multiple applications. So you might have an application server for SAP or Oracle, or the ERP system that we use for North Park for you to register. It could be an application server that has our Microsoft 360 on it and all files, and that includes Microsoft Teams and maybe even a separate one for Canvas. Web services, small pieces of code that are accessed via application server that permit interoperable machine-to-machine interaction over a network. Again, this has to exist, but it's transparent to the user. You want it to be transparent to the user. If the user, one of the things that it does is maintain security to some point. I shouldn't be able to see certain files within the North Park system. I mean, I shouldn't be able to, on IBM 360, or Microsoft 360, access your homework files until you want me to access them. Or, the university presidents or CFOs, the spreadsheets, and, I shouldn't be able to access the personnel server information for anybody but me. And if I had some employees, part of what the employees might have in there. So this is important. So the API, Application Program Interface, are programming hooks or guidelines published by firms that tell other programs how to get a service or perform a task. That includes some of the security. Not all information should be available to all people. All people should have information to all information that they need to do their work or their job. But beyond that, you should, it's a need to know basis, or a need to, it's a need to know basis, thinking from the CIA kind of terminology. Service-oriented architecture. Well, it's a set of services built around an organization's processes and procedures. It's how you decide to structure all of this. Do you have to know what all these things mean? People are going to bandy these terms around, and sometimes they sound like they all overlap and kind of mean the same thing. So the purpose of a class like this is to get familiar with it. I would suggest this. What most people do is when they hear a term, API, SOA, blah, blah, blah. If you're in a meeting, you don't understand what you say, I would interject. You learn to interject and say, hey, listen, remind me what that is again. It's like abbreviation and, this is just alphabet soup. I'm getting confused. And you can't say it every time. I mean, if you ask twice and what API is, you probably shouldn't ask a third time. You should probably remember. But the thing is that people use these terms and they don't always use them right. I learned this when I would think most people don't understand what an inventory turn is. And yet everybody talks about inventory turns all the time like they know what they're talking about. And I know they don't know what they're talking about. Because, I just know. All right, multi-tiered distribution system. So you got a bank. You got the company's systems and servers, and you got clients. And clients access the bank many different ways. It could be from a cash register, it could be from an ATM, it could be through a teller, which uses an app. It could be on my home banking system that I access through my computer, or it could even be through my phone. Now, this is a bank. You want to talk about some of this stuff. Application server, who gets to see what data and who gets to send and receive what data. Well, I've often told the bank when they ask for my ID when I'm depositing a check, I'm like, you don't have to ask for anybody's ID if they want to deposit money into my account. Just let them do it. But I really appreciate the fact that you ask for their ID if they want to take money out of my account. And if it's not me, don't let them do it. Well, that's what a teller does. You still want an ATM to do the same thing. You want phone-based interfaces with the bank to do the same thing, et cetera, et cetera. So here's your web server that interfaces with all your customers that are not actually in your bank talking to a teller. It goes to an app server and it goes to the database. It's really important to know how much money I have in an account, and how much the web server is telling me I have an account should be the same as is actually in the account, and that same number should be actually in the database. So application software, if we talk about apps, desktop products, and enterprise. Chunks of code are accessed via application server, or sometimes referred to as web services. Application program interfaces are used to describe the same concept. See, it gets a little confusing. It's the same thing with ERP system. I told you before that they looked at ERP system on the same level as supply chain management, CRM, and those things. And I look at ERP as an umbrella which covers all of those other applications. So you got to know the nature of the company that you're talking to and the way they use some of these terms. For managerial purposes, you can think of web services and API as doing pretty much the same thing. Pieces of code that can be used to summon other programs to perform a task. Do you need to know the difference? No. As long as it's transparent to the user, it doesn't matter. Firms other than Google use Google Maps. Spotify's API allows Uber to modify its app to play a rider's playlist through a driver's smartphone connected car speakers. Uber's API allows United Airlines to build an app that can summon an Uber driver if they want. So these things can talk to each other and have permission to communicate with each other. I didn't even know those things were possible. Expedia, affiliate network. I don't know who's using Expedia these days. So anyway, it's a travel system. Allow partner sites to book hotels and other travel services through their own apps and websites. Sometimes I would think that Expedia might work in the background of some of these other airline systems. They might be, since they've developed the code to integrate hotels and rental car and all that, why would I want to write my own code to do that? Why don't I use Expedia, but it looks like I'm on the United Airlines website or Aer Lingus website. But anyway, you have an Expedia affiliate network, access to Expedia's travel inventory, technology, and support team, and it's United.com, United app, Aer Lingus.com, Aer Lingus app, Greyhound, and I don't know what Hipmunk is. I probably have to look it up. So here's how do you share data across this. EDI has always been a way of doing that. Electronic data interchange. For most companies that do, this is the first when I heard data being transferred between companies, between ERP systems. It was an EDI transaction, and the finance people, especially if you're transferring funds, and if you're transferring sensitive company information that's not financial to the other company, and you don't want competitors to see it and do it. You want to do it in a secure manner, and EDI became a platform, if you will, on which to do it. Extensible markup language, XML. Tagging language that can be used to identify data fields made available for use by other applications. I think XML and this other one, JSON, is JavaScript, object notation, a popular data interchange format. I think these are used a lot of times more on web services. EDI is used more between companies, and it's been around since then. The first ERPs came on the scene and became popular in the 90s. People were doing electronic data interchange, maybe even before that, for all I know. But again, it's transparent to the user. If I want to transfer money, I want it to be done in a secure, safe way, and I would like verification that the money I sent arrived, or the money that was sent to me arrived and is in my account and therefore usable. So you have to have these formats for data sharing across companies and even within your company between databases. So if you look at, here's some examples of JSON and XML coding. And I don't know, I'm not sure what the coding is doing here, but it obviously is creating fields for your employees, and it gives you a first, middle, and last name. And then the XML example is, gee whiz, it looks almost the same. Instead of using set notation brackets, it's using less than and greater than signs. But it has, you can see that it does the same functionality in a different way. I think these are actually defining the fields. Those are the three fields. So I don't know if your name is Jose Luis Gonzalez de la Vega. I don't know where the first and last name is. And in Chinese, the first, what might be your common name and your last name are, the last name is first and the family name is first, and your name is second. So it's good to know things like that when you're transferring things back and forth. All right, so when you're writing software, there's a language in which it's done. Eventually, the language is, if we go back to the language, we write it this way because you can basically read it and recognize what the symbols are. If you understand why they're doing it this way. And oftentimes the indenting is we're defining a field called employees, and then I think it could all be on one line. but I think they separate it like this so it's easy for people to see in an outline format. And it's first name, last name, first name, last name, and it's got all the people in here, and it's defining these people in the database, or the people that it's being transferred. The names that are being transferred. Same thing here. All right. The machine sees it as all zeros and ones, lots of zeros, lots of ones, lots of zeros and ones, all intermingled. Well, who can type that way? Who can write things that you don't know? You don't know what you're talking about. I don't know what I'm talking about. I can barely do binary math. If I was to take the number 74 and try to write it in a binary notation, it would take me probably about 10 minutes, 15, 20 minutes to figure out, again, how it's done. And now if you ask me to do 325 after I've done 74, I can probably do it quicker, but why? There's probably an app where I can put a number in and it'll give me the binary location. Why do it? There's no point. So we write, the language the programming language is in between the zeros and ones and what is in your mind that you want to do. You know, in your mind, it would be nice to be able to dictate into the computer. I'd like to send the names of these employees to that software. And it's, Bill, Tom, Fred, Jane, Maria, Lucinda, whatever, Juan, Wang, and I say, and I only want you to send their first name, last name, and I want you to send their job title, and I want you to send their work phone number and email. All right, well, how do I program that into XML or JSON? That's a different thing. I can write that code to do that. Or maybe when I write the code to do that, it comes up with a click screen. What fields do you want to send? And then that I'm not doing any XML programming, I click, I want to send first name, last name, title, department, work phone, work email, and then what names do you want to send? Oh, I don't know. What am I going to look at? All employees? No. It's like an email list in your computer. I start typing your last name. And then, oh yeah, that's what I want them. And I type a lot of the last name. I want them, and it does that. So the coding is kind of in between the user interface even. So if I'm writing the programming language is what makes the user interface do what you want it to do and eventually turn it into zeros and ones that your user computer can interface with the various apps and eventually with the servers to accomplish the tasks that you want to do. So there's all kinds of language. There's C programming, C++, seems to be popular, Visual Basic, Java, SQL. Most professional programmers use an integrated development environment, IDE, to write their code, includes a text editor, debugger, and other useful programming tools. Not having written code since 2003, 4, or wait, I'm lying there. I think the last time I actually wrote code was, why would I say 2000? It was like 1985. And I wrote some sophisticated programs, but there's no need to write them anymore. There's all kinds of things that exist. Now I probably should learn some new languages, which I'm about to talk to you about. An application that, so an integrated program development environment, an IDE is an application that includes an editor and a programmer's word processor, debugger, and compiler, amongst other tools. These are used in the JavaScript, VBScript. I've actually dabbled a bit in R, and there's a programming, an IDE for that, integrated programming development environment. And for Python, these are used for big data analysis. At first, R was the program everybody used, but people have moved a lot to Python now. And Apple has an Xcode IDE, where people that are writing apps for Apple, write it in an environment that looks like this, and it looks like this. What is this? A Yelp page on your phone. So it debugs. It tells you you've done things wrong, and it saves your code for you in case you want to copy and paste your code in someplace else for using the same kind of thing. So, popular approaches to developing software. Back in the day, I was, the program, when I did my own coding, I wrote specific application software in either a programming language called BASIC or Fortran, which was kind of like BASIC and Fortran were pretty close to the same. Fortran used more, what do we call it? Subroutines that you could save and use in other programs. BASIC was a little bit more straightforward, but they both kind of did the same thing. They were kind of mathy engineering, and that's the kind of programming I did. Probably my greatest accomplishment was writing life data analysis programs using reliability engineering statistical tools of Weibull analysis and such things. And having written in the 80s, I didn't have access to a stat package, which is, it's all there now. There would be no need for me to write this software again because it's already been done and written by someone like me that started writing their individual stuff and then created a business out of it. Except that I didn't create the business out of it. I went on to manage businesses. I had to write my own code for every statistical distribution. Well, there's no need to do that twice. If someone's already done it, just use it. That's the whole point of Python and R, these open architecture environments in which people write. People can share stuff. If you want to share your software, you can, and other people can use it. So there's many ways of doing it. One of them is I could write it myself. The other way is waterfall. It's a sequential approach to software development. That means you don't go to B until you've finished A. So there's a linear approach. I'm going to do A first, I'm going to do B, I'm going to do C, I'm going to do D, I'm going to blah, blah, blah. This is a classic but increasingly out of favor approach because it can prevent scope creep, which we'll talk about, which is expansion of the scope, but it's very rigid and it can take time to implement because you don't start B until A is done. What most software writing done is now, if I'm going to write A, I'm going to write B, I'm going to write C, I'm going to write D, let's do them all at the same time and save time. So this is Agile and Scrum. Well, let's put some definition around A, B, C, and D. First of all, programming is way different than when I did it in that the actual algorithms to do the calculations that you want might be important. But I'm designing I might have might be, what are the user interfaces going to look like? What are the graphical user interfaces going to look like? What is my screen on my iPhone going to look like when I'm trying to use this app? What does it look like on my mainframe when I want to do the same thing? And what does output screens look like after I've done that? So that could be A. B could be, what's the code behind that? C could be, what's the algorithms we're going to use to take the input from the customer and turn it into this, that, the other thing. The user and do the search and highlight everything. I'm thinking, again, since they had a Yelp kind of thing up there, let's stick with that. How do I do all those things? So Agile says, it's developing work continually and iteratively with the goal of more frequent product rollouts and constant improvement across smaller components of a larger enterprise. So I might have a user interface team, I might have a algorithm team, I might have a search team, I might have a database management team, I might have, whatever. And you have them all working together and you've given them each separate task. So hey, listen, I don't really like the user interface on this. Why don't we tweak that? And then some morning you wake up and you can't access your Yelp because it's updating, automatically. and it's because they changed something. Doesn't matter to you what they changed. And they always say we've done it to improve the user interface or fix a bug or do this or that or the other thing, and boom. So that's agile approach to things. Scrum is approach to organizing and managing agile products that breaks deliverables into sprints, delivered in 1 to 6 week increments by teams of less than 10. A scrum is like, from rugby, where the people all gather and, move the scrum and try to get the ball. So the roles, so you have a product owner, a scrum master, and team. You have a product vision, you have a product backlog, a sprint backlog, task board, all this kind of stuff. This is stuff you can cover in project management. Software and project management, software development and project management obviously go hand in hand. Software development is a project management application. So these terms, agile development, Scrum, are things that you'll probably hear bandied about as well. So where are we here? The other thing is, beyond the price tag, what's the total cost of ownership and the cost of tech failure? Well, total cost of ownership is all the costs associated with the design, development, and testing of implementation, documentation, training is so important. I mean, you could have a software that's perfect, but if you don't train your people how to use it well, and guess what? Once you graduate from college and you're out in the adult world, your ability to learn things seems to drop off dramatically. And maintenance of the software system. I mean, you're not done. It's not a system that you can just turn on like an app on your phone and it works perfectly. There's an army of people behind that app making sure it stays up to date and is working properly. The cost in the case of a software system is the design, development, testing, implementation, documentation, training, maintenance of it, because you're going to find occasionally a bug that you hadn't realized was there, and then you have to update it. Things change. Computing changes. All of a sudden, you can do what you want to do easier. Should you do it the old cumbersome way? No, let's reprogram it and make it easier to do. We could have never included this feature before, but now we have computing speed and some interface with some other software that allows us to do that. Let's do that. So you have versions too that are coming out. And then every time you have a version, do the users like the version or do they not? Well, the whole point of Apple was to try to create those user interfaces in a way that were so intuitive that you didn't need much training. But a lot of times when you get a new app, if you're like me, it's where did the back button go? Where did the, this button or that button go? How do I do that now? So that's important. Why do technology projects fail? Oh my God. There used to be, when they first implemented ERP systems, there were horror stories. There's way less now. One of them is poor goal setting, including a lack of clarity or ability to achieve goals. So if you don't know what you're setting out to do, you won't know if you achieve that or not. Weak project leadership and project management, most certainly. Non-existent or limited executive commitment. It's all software has to be led by the business. And that means there has to be a C-level commitment of it and knowledge of it and have some input into it. Poorly forecast resource needs and inadequate access required to the resources. If everybody says, we need a team and we're going to do this, and these people are going to be full-time, and those people are going to be part-time, sometimes you have trouble with the part-time people in that their management agrees upfront to let them participate, but then when push comes to shove, you can't do that today. You got to stay here and finish the monthly closing or the inventory count or whatever the case may be. And that will slow your project to maybe to a halt. Project complexity. The project has to be complex enough to achieve the final goal. But if you added extra complexity to it, people hate that. Scope creep. This is the kind of adding bells and whistles as you go along that you started with a project to, let's use an analogy in agriculture, to improve the yield of corn in fields in Iowa. And the next thing, by scope creep, you know that you've extended it to other products. You've done this, and before you know, you're solving world hunger when your initial objective was this. So scope creep has to be managed very well. Scope creep is also a little old lady's hired me to paint their house. Oh, young man, would you mind changing a light bulb in my house? Oh, yeah, sure, lady. I don't mind doing that. It takes 2 seconds. I have my ladder. Let me go inside. I change. Oh, you're such a wonderful guy. Thank you. Oh, yeah, no problem, lady. And the next day she says, oh, young man, I've got some people coming tomorrow to do something, and I need to roll this rug up and move it out of the way so they can, bring a new refrigerator in. And yeah, sure, lady, I can do that. It takes 2 minutes. I'm done with my day before I go home. You roll up the rug. Oh, and by the way, I got to, can you look at the sink? It's leaking. And or I got, I just scuffed the wall. Would you mind just touching it up with the paint? Here's the paint. And next thing you know, you're like her handyman, and all you were hired to do was paint the garage. That's scope creep. So you've got to manage that and make sure that it doesn't happen, because every functional area, every C-level manager is going to ask for their own bells and whistles in a project, and you don't have the time and wherewithal to do that. You need to control that very well to manage scope creep. So ineffective project reporting, poor communication. This is like a mini project management course, which we do teach, and if you take it, I teach that. Inappropriate technical choices. You've picked the wrong software for your company, for example. You didn't test it and deploy it correctly. You have squabbling between functions. You have that silo between functional areas, or between internal and external politics of if your software project is extending to customers and suppliers. Time and delivery pressures. There's 3 things. There's time, there's the scope of the project, and there's the cost. And that's called the project management triangle. And you've got to decide, and you've got to know which one is important to your management. Like they may say, you need to implement this software, and it has to be done in the 3rd quarter, or it has to be done in the 1st quarter of the year, so that we're a retail business, and when Christmas time comes, we want this thing operating like crazy. So if you don't get it done by the end of the 1st quarter, March of this year, we're going to have to delay it to next year, because I can't risk my holiday shopping season with being compromised. So schedule is really important to them. So if push comes to shove, what do you trade off? Cost, throw more people at it, or you reduce the scope of what you're going to do and then catch it on the 2nd iteration. If you're NASA, what's most important? The scope of the project, the safety of the space. You can't have things blowing up on the launch pad or shortly after launch, like unfortunately happened to some of the space shuttle, even with the best of intentions. But that scope is more important. They will throw more cost at it. They will delay the launch, but they want to make sure they do it right for the safety and well-being of their people. So you need to know that. Time and delivery pressure. So that project management triangle fits right in there. Capability maturity model integration, CMMI. It's a process improvement approach that can assist in assessing the maturity, quality, and development of certain organizational business processes and suggest steps for their improvement. Well, this is right into my sweet spot here. What are you doing with any software? You're automating the information interchange for a business process. This is all about business processes. This is all about business process improvement. So I'm of the mind that all software has to be accompanied by a knowledge of business process. What is the current process? What is the as-is process? What does the to-be process look like? What has to be done to get from here to there in an information standpoint, which is the software part, and training the people on the new business process. It's a socio-technical environment, and it must be done that way. Lessons learned from failure and rescue of healthcare.gov. Served as this was a project that was done. They wanted to get it up as soon as possible. And they did, but they weren't interested as much in the scope or the cost that it took, and those were the trade-offs. So the scope was traded down, and the cost probably got out of control. Served as a national healthcare exchange where people could shop for and enroll in their healthcare plans. Subsidies offers for low-income enrollees, assist those eligible to sign up for Medicaid, but the system was riddled with problems. Bug-ridden, flawed design, prevented sign-ups, extremely high cost, lack of clear authority over website functioning, could not handle national demands, and lacked common measurement and reporting systems because they traded off scope to hit a schedule. Project management triangle, pure and simple. So clear leadership brought in with responsibility and authority, team of seasoned technologists hired. They set clear priorities, coordination, implementation, stand-up meetings. What is a stand-up meeting? It's a thing you have in the beginning of the day. You don't come in and sit down with a cup of coffee around a table. These are 10-minute meetings where you stand up. I've seen them where people had a real hand grenade, but it was a dud. You know, I mean, there was no it was benign. There was no gunpowder or shrapnel, inside of it, but it was a hand grenade. And you have, what does it take for a hand grenade to 10 seconds, 15 seconds? But they would pass a hand grenade to each person. You'd have 15 seconds to give your update for the day or what you needed to work on, and then you would come up with a plan. So if I came up and said, hey, we're on target today and everything is going well, I just pass it to the next person. He might say, listen, we ran into a bug yesterday and this blah, 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 the summary is what it is, and it may delay us. Well, then the leader of the team may say, okay, so we're going to meet after this and we'll go through it in a little bit more detail, and the rest of you go and do your job. So that's the stand-up meeting. They're fun. There's a lot of pressure. So results reporting, coordination, and implementation, and over 8 million users signed up by mid-April. They did a good job. And that's it. That's the presentation of this chapter. I hope it was helpful to you, and we'll talk again soon. Thank you very much.